If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all to this new lecture in intermediate level. So we will complete that graph part of inverse trigonometry today. So in this lecture we will see tan inverse tan, tan inverse tan, tan inverse, cot inverse cot, cot inverse, similarly sec and cosec. Okay, then let's see all these graphs. So this will be a y equal to x line for the entire x-axis. So it is a, that's why it is given a ray. That means it is continuing in this direction. It is not fixed at some point. It is just going in this side and it is also going this side, both sides. It is just a straight line passing, going through infinity and minus infinity. Okay. Now if you do the same thing now, tan inverse tan x. So what is the output of tan inverse? It is minus pi by 2 pi by 2. Input you can give here any value because tan x can take any value. So if you input between minus pi by 2 to pi by 2, then input output is same. So from minus pi by 2 to pi by 2 it will be same. But it cannot be minus pi by 2, it cannot be pi by 2. So you can put a circle there. This point is not there. So same here. Again if you cross again 90 degrees, so you are coming at here. That means this is your x. So what should be your output? So this is your, if you give this x, then tan is negative. So your output is here. So your x is input is here, so your output is here. So how, what is the relation from input and output? This is your x dash, so you have to bring it here. So how to bring it here? This direction. That means your x dash will be equal to x minus pi. So this is your output. Actually x dash is your output. So you can think it in other examples also. This is your x dash. So x dash equal to y, that is y, which is equal to your, this is your x, so you have to bring it there. So pi minus x actually. So this is not that way, because it was same quadrant from 1 to 2, 2 to 1, so it was okay. Because 1 to 2, 2 to 1, it is always pi minus theta. But here it is different. From here to here if you go, it is pi. From here to here if you go, then it is minus pi. So reverse actually, what I have told you for sine and cos also. The idea is same. So same here, this is your x dash, that is your y, which is equal to your 2 pi, that is 360, minus what is your x, that is 210. So again it is same here, so that's why it is also doesn't make any difference there. But here it will make difference, because if you want to go here to here, then it is minus. If you want to go here to here, so you have to see which one you have to go. This is your output, so you are writing your output in terms of your input. Input is x, so that's why it is x minus pi. No need to remember it also. You just check up to this much, you know. Again these points will not be the answer, because pi by 2 pi will not be there, so everywhere there will be a circle. So you check with pi. So tan pi is 0, so tan inverse will 0, so pi equals 0, so it will be this. And there will be discontinuity in this one, because your output cannot go to minus pi by 2 and pi by 2. So therefore discontinuity at minus pi by 2, 3 pi by 2, all 90 multiples, there will be discontinuity. Same for cot of cot inverse x. We have already seen this is x, so it will be aperiodic. This is periodic, you can see it is repeating after pi, like your tan x. Tan inverse, this one is aperiodic. Again cot is again same aperiodic, it will be again y equal to x passing through 0, 0 with an angle of 45 degree. It is a continuous line passing through this. Again cot inverse cot x. So what is the output of cot inverse? 0 to pi. Input you can give anything, but if your input is from 0 to pi, then it will be exactly same. From 0 to pi it is same. Again your output cannot be equal to 0 and pi both, so that's why you will put again. So again there will be a circle here, you can put it there. These points are not in the outputs. So this is a discontinuous function, like your normal tan x and cot x also. So same idea. Again if you are moving beyond 180 degrees, so if you now you let us see it clearly. Now if you are going beyond 180 degree, that means you are coming here. This is your x. Okay, what is here? Positive. So this will give you positive. What is cot inverse positive value? The answer will be here. So this is your x dash, this is your y. So how to come to this y now? This is your x dash y using this one. So again you are coming back. So because moving clockwise is back, so it is a x minus pi. You can see your y is x minus pi. So similarly all other graphs can be drawn. I am not drawing it. So again you can see it is the time period is here pi. You can easily draw from other quadrants also. No need to remember this one. In the exam you can, by putting the points also, then you join, then you know that it is a straight line. So you can easily use the straight line formula, you then find it. Put some points. Initial one you can do it this one, and next you put it and then join it. Remember which one is discontinuous, which one is continuous, that's all. Again cosec of cosec inverse x. Now you see what is cosec inverse x. Your domain is greater than 1 for cosec inverse. It should be 1 to infinity or minus 1 to minus infinity. That is mod of x is greater than 1. Similarly your output for cosec is also same. So it will be outside that 1 to infinity. It will be from 1 to infinity and minus 1 to minus infinity. So you can see outside it is y equal to x. So it is a line, it is a ray originating from here. It will go at this side. And this is also a point in the, there is no circle. It is including this point, because cos inverse can be 1. cosec can take 1 also. So that's why from here it will be a ray this side, from here it will be a ray side. In between there is nothing, because the domain is from 1 to infinity, range is also from 1 to infinity. Similarly, -1 to -infinity, -1 to -infinity. Now similarly, cosec inverse of cosec x, it will be your normal your sin inverse sin x, same format. But here, what is your output? Output is between -π/2 to 0. 0 you cannot include, 0 to π/2. So input you can give anything, cosec inverse x, cosec x, but you cannot give 0. Okay, but if your input is in between these two, this range, then your input or output same. So -π/2 to π/2, the input output remains same, excluding the point 0. So it is you like sin inverse sin x. You can see this one, this graph, this one, same line, because π/2 to π/2 it will be same. Same cosec for π/2 to π/2 it will be same, but 0 it cannot be. Now you can extend this one. I am not explaining now this one. For this second quadrant, if you go then like your sine it will come, because cosecant sine there will be similar graphs, but these points will not come, 0, pi, 2 pi in cosec. So that's why these points are given as circles. So this point will not come. Similarly with sec inverse sec x, now you can have an idea. Sec of sec inverse L will be like your cosec. Again it will be greater than 1, then it will be a ray outside starting from this point. This point is also in the graph, because sec can be 1. So it is going from this to a ray at an angle of 45. It is also a ray at an angle of 45. In between nothing is there. Sec inverse sec x, like your cos x, again same, because your output from 0 to pi, but not including π/2. So if your input between these two, then your input output same, so y equal to x. But these points are not included. Now the π/2, also π/2 is, because sec π/2 is undefined. It is like your same graph. So I have drawn it to understand, to make you understand this one, like your cosec only, because if you go beyond 0 then it is negative, but again it is positive, so cosec positive will come here. So this is your actual output, this is your actual input, so output is minus input, or y dash, so this is y equal to -x. So similarly all this line can be done. This is also a periodic of 2 pi, that is your like your cosec. If you like the video, then press the like button and please give your valuable comments in the comment section.